Nuclear energy may bring to mind large power plants, major infrastructure projects built to generate electricity for the grid, serving millions of people over many decades. But around the world, engineers, governments, and energy companies are also exploring a different model for deploying nuclear reactors. These are small modular reactors, or SMRs. They are designed to be manufactured on production lines as modules that can be transported and installed. Factory production offers the potential to lower costs and reduce timelines, creating a standardized product for multiple applications. The growing interest in nuclear is driven by pressures facing global energy systems, such as rising electricity demand, the need to cut emissions, and a renewed focus on energy security. SMRs are attracting attention because they offer a new delivery model for nuclear energy. There are over 100 designs in development, with potential applications for energy users such as data centers, heavy industry, and countries with smaller electricity grids. So what are SMRs, and why is everyone talking about them? SMR stands for Small Modular Reactor. Small means the reactor is designed to produce less power than a large conventional reactor, often up to around 300 megawatts of electricity per unit. But small does not mean insignificant. That is still enough power for a town, an industrial park, or a gigafactory. And being suited to smaller tasks mean SMRs can fit in smaller locations, where clean energy is needed. Smaller sites, smaller grids, and smaller countries. All of this expands the role that nuclear can play in the energy transition. The second word is modular. Instead of being constructed from the ground up, many SMR designs aim to manufacture their most important parts in factories as modules, then transport them and assemble them on site for faster installation. A small number of factories could efficiently supply modules for SMRs around the world. The goal is to make nuclear deployment more repeatable. The more often the same design can be built, using the same supply chain and trained workforce, the more predictable the process can become. That is one of the main reasons SMRs have attracted so much attention. Finally, the R stands for reactor. SMRs encompass a range of reactor designs and types, all of which are evolutions of existing designs rather than entirely new technologies. They are not just small reactors. They are an attempt to change how nuclear power is delivered. Traditional nuclear power plants are major infrastructure projects. They take time, require large upfront investment, and must plug into grids with enough demand to absorb a lot of their power at once. SMRs are being explored because they offer a new approach to deploying nuclear energy. Modularity, factory fabrication, and series production. This approach could make deployment faster and delivery more certain. SMRs are also attracting interest because different types of customers are interested in them. Traditional nuclear reactors are often commissioned and purchased by governments and utilities. Now companies, including tech companies operating data centers, are actively involved in development and deployment of SMRs to provide energy for their operations. In this way, SMRs complement traditional large-scale reactors by offering additional flexibility and wider deployment opportunities, from electricity supply to small grids or industrial users like data centers. There are several SMRs already operating and under construction. China is demonstrating progress with the world's first modular high-temperature gas-cooled reactor entering commercial operation in 2023, and successfully completing turbine test runs for the ACP-100 Small Modular Reactor Demonstration Project in 2026. The academic Lomonosov floating nuclear power plant in Russia's Arctic region has generated over 1 billion kilowatt-hours of electricity in 5 years of operation. Construction and deployment of SMRs is expected to grow in the 2030s, with projects starting around the world. At Canada's Darlington New Nuclear Project, Ontario Power Generation is building a GE Vernova Hitachi BWR X300 SMR. In May 2026, its basement module was installed as the foundation of the reactor building. a milestone for the first SMR to be built in a G7 country. The BWRX-300 is being co-licensed by the Canadian and US regulators, and the same design is planned for deployment in Poland. Rolls-Royce SMR and Great British Energy Nuclear have signed a contract to begin work on 3 Rolls-Royce SMRs at Wilver in the UK. The Czech nuclear operator ČEZ has also signed a contract with Rolls-Royce SMR for a proposed new reactor at Temelín. SMRs offer greater flexibility in how and where nuclear energy can be used. Some designs are intended to provide both electricity and heat, broadening nuclear's role beyond grid supply into industrial processes, district heating, desalination, and alternative fuel production. The academic Lomonosov already provides heat to the Arctic town where it is based, and China's modular high-temperature gas-cooled reactor has been connected to the heating grid. Industrial giant Dow Chemicals has partnered with X Energy for high-temperature gas reactor units at its manufacturing site in Texas, while Kairos Power is progressing its Hermes demonstration plant with Google to develop an advanced reactor fleet. Their smaller size also makes SMRs suitable for a wider range of sites, including smaller grids, remote locations, or existing industrial and retired fossil fuel sites where a large reactor may not be practical. And because nuclear provides power all day and all night, whatever the weather, SMRs, like large reactors, are complementary to other energy sources such as wind and solar. SMRs will not be the only solution for every country or every situation, but they are being commissioned as an important part of many future clean energy systems. Their potential lies in a different delivery model: factory production, modular installation, and repeatable designs that can be matched more closely to specific users, sites, and energy needs. For some countries, that could mean dispatchable power for smaller grids. For some industries, it could mean reliable, low-carbon energy close to where it's needed. And for the nuclear sector, it could mean testing whether reactors can be deployed more like a standardized product built in series rather than one-off projects. You can explore World Nuclear Association's SMR Design Database and Global Project Tracker to see how projects are developing around the world. And for more information on nuclear energy and technology, visit World Nuclear Association's Information Library.